Let's explore the world together.
Be prepared and load our backpack.
Hello Pew community. In this video, we're going to show you how to win the weight carrying contest. As you can see, Robot Pew comes with a small backpack. So even though it can carry something, but you definitely cannot win the weight carrying contest, because in the weight carrying contest, we're going to compete to see whose robot can carry more weight and walk in a stable way and can walk some distance in the shortest time. And in this video, we're going to show you how to use the Tinkercad to build a big backpack. Big backpack that can be attached to the back of a robot pew. As you can see in the back of the robot, there are 4 Lego pins. From here, then you can attach anything. If you know 3D design, then you can design a really nice backpack. And in this video, I agree, this backpack, it is big, but it might not be the best solution to win a contest. Okay, anyway, let's show you an example so that you can build your own version of backpack to win the weight carrying contest. Let's have a quick introduction about how we build the backpack. So as you can see, this huge backpack can be attached securely on the back, and as you can see, this backpack, it's straightforward to build. Basically, it is a big cube, then you dug a hole in the center, then you attach the Lego pins to one side, and the distance of those Lego pins is 16 millimeters. Okay, if you don't believe me, you can use a caliper to measure the distance between those pinholes. Okay, so now once you design this in the Tinkercad, you can export it as a STL file such that you can print out in a 3D printer. Okay, let's go to the Tinkercad design procedures. Before you do the 3D design, you need to do some measurements. The best way to do the measurement is buy a high quality caliper. So you turn it on, then 0. Right? Make sure it's starting with 0. Then I will do some measurements. Let's say, because to design a backpack, I usually want design the backpack is bigger than the width of the robot pew. And so as you can see, the measurement I put it there, it's about 70. It's opposite, so it's 76 millimeters. Let's start a 3D design. This is a final effect, and what you need to log into tinkercad.com and create an account there, and you also need the 3D printer. And after you design a model, you can export a model and print it out with 3D printer. And the filament, you can use PLA or PETG or ABS to print it out. I would recommend use PETG because that will balance between the strength and flexibility, and also how easy to print. And also you need some measurement tool, basically calipers, to do some measurements. Make sure your design is precise and fit into a robot pew. In order to get to the Tinkercad, you can either click the RoboGym link in this web page here, and all the teaching material that's in a class called Pew Community, and the Tinkercad class code it is showing here. You can either enter the class code or just simply click join the class by this. After you click that, then you can just directly go to this page and you can click tinker this. Since I already created, let's just go to, then it will lead you to this page. Then we got a lot of projects. Basically is this project, and when you open it, as you can see, I already built one model for you. This is totally an example, okay? And in this video we're going to teach you how to build this model, but you should build your own version because this solution might not be the best of all the solutions, okay? But you can definitely copy and paste something here. Okay, let's to start with, for example, you can copy and paste the pin here. So let me show you how to build this. Okay, so first of all, when you get into this, I will make a copy of it by press Ctrl D. After you select the model, then press Ctrl D. Then you can use press the shift key or something to move it out. Okay, what I need to do it is, as you can see, then you can ungroup it. I use this ungroup key to ungroup it, because what we need is what you need the you need to have, let's reverse it to, you can see how I build it. Okay, so what you need is this pieces. Basically that's the starting from this class link. When you click this link, you will go to this web page. Then you just click tinker this, and then you can rename this project to something else. Okay, then by clicking here, for example, here you can click, say, and change the name to backpack 2 or something. Okay, so in this project I gave you the final example of the backpack and also one Lego pin such that you can attach to your backpack design. Okay, let me show you how do I create this. Right, first of all, you just need to create a bucket. So then you define the size. So I would recommend, say, 76 by 76 and also height is also 76. Ooh, hold up, I need to move this to here, a little bit to here. So see, that's 76. Okay, so basically that's a huge, really huge backpack. Okay, so in order to get those like smooth edge on 4 corners, I usually you can simply tweak this. See, I just add, you can type in as a number, so 5 or something. Yeah, the more you type, the more curve it is. So if you type a lot, then this cube become a ball now, right? So I will put like 3 to start with. Okay, say the more step you put here, you will make the cube more smooth, right? So then this is what we need to do. So this is, we create an outside view, right? So then what I want to do it is, I will make a copy of it by press Ctrl D. Okay, then I change the size. Say I change the size to, because if I want the wall thickness to be 1.5 millimeter, then I will make a copy of the object and shrink it down by 3 millimeter in length. So that would be 73. And also I also change this to the height to 73, and also change this to let me shift a little bit, change this to 73. So since there are 2 objects here, right, so I can change the color to something else, so you can see, and also make it hide it. See, there's another cube inside it, and you can show it, so we can show offline. So I need to center the smaller cube in the middle of the big cube. So then I make a rectangle and select both objects here. Then I need to align them here. See, I basically make alignment, make sure that they are all exactly in the center. In this case, the smaller cube will be in the middle of the big cube. Now, what I can do it is I will basically make the smaller cube to be empty. Okay, make it basically make it hollow. So okay, so then hide it. Let's see. Yeah, that's a smaller one. It is hollow, and the bigger one, it is bigger one's 76. Okay, so how many? Let's make sure how many pieces here. So yes, we only have 2 pieces. See that? So then I will make another. I will merge 2 of them together. So it will create a shell, because I make a big cube and cut off small cube in the center, and we have a shell, right? So then I will prove to you. So then you just make a cube, because you need to cut off the top. So then I make a top to be 100 by 100. Then I move it like this to the top. Then I shrink it down a little bit to cut into it. Then I cut off the shell with the empty cube, and I do a merge. Ta-da! Oh, see, it got a container now, right? But I probably not doing well, because I forgot to. I supposed to cut out a little bit more on the back, right? So let me cut one more time. So I cut up the top. Now you got a really nice container now. See that? Now what I need to do it is I need to move this pin to the side. I make a copy of it. Then I use this place key. See? Then I drag it to here. Ooh. Let me take it back. So you can basically select it and use the key to move it back and forth a little bit, and you just make sure it's contact the surface, right? So then I make 2 of them. I use Ctrl D, copy it, then I shift it by 16 millimeters. So 1 2 3 4 5 6. Now they are 16 millimeters apart. Okay, so I think I can move this back a little bit so it's easier for me, right? So then I need to make a copy of it one more time. Control D. Then I shift it by another 32 millimeter. 1 2. Oh, let's take it back. Okay, so I make another copy of it. Control D, and shift it by 16 millimeters. 2 3 4 5 6. Then make another copy of it. Control D, and shift by 16 millimeters. 1 2 3 4 5 6. Now I group all those 4 together as one object and try to align with the cube and align in the center. Now as you can see that now they are in the center. Now I can basically move this back, so those 4 pins contact the surface, right? So, and I will adjust it to make to use this to move this up a little bit. See that? Okay, So now I will select all of them and merge them into one piece, and tada, you have a big backpack now. Then you can select the new object you make and export it as your download in the download folder, say huge backpack. Okay, so and let's go to next step to 3D print this out. Then we can open the Cura software to do the 3D printing. First, let's load the model. The model, it is the export model we did. It is huge backpack still. As you can see, it's loaded here. It's like this, right? So I pick PETG to do the 3D printing, and usually we have to enable support because those pins they are in the air, so we have to use support. And also for those like curvature area, they also need support. So once we slice the model, as you can see, the green area, it is where the support is supposed to look like this. Then if you satisfied the support type, then you can just send a print plate, then you hit print, and after that I have a 3D printer that has a that you can send the file remotely, so and we can take a look at that, and the printer already takes action. So after about a couple hours, then you can see your model print out. And this is what we get out of from the 3D printer. As you can see, there's a support attached to it, and you can simply remove those support and use the filer to clean it up and smooth it. Then we can attach to rubber fuse back. As you can see here, I put a backpack in a backpack. See, right? It can work. So I think at this moment is a little bit based on the law of physics. So, but you might have some difficulty to work now. So. As you can see, I make another backpack. I dig like 3 Lego pins on the bottom. I try to mount to the top of fuse head like this. See, the Pew package provide those Lego pins. I take them out from the package, and be careful, don't let little kids like to get those small pins because there's a choking hazards. The robot, it will fall. Then you insert the pin to see there's a small holes on rubber fuse head. you insert a pin like this to the top of robot fuse head. That purpose of the pin is supposed to use to mount the Lego pieces on the top, such that you can mount like a AI camera or mount any Lego pieces you want on the top. But at here I just built another backpack that has three pinholes on the bottom, so then you can attach to the top. Now the robot fuse looks like this. It has a huge backpack on the back, and also has a big parapet on the top of head, and such that I can put robot fuse friend Penny either on the back, so they can go have fun together, or I put the Penny on the top of robot fuse head. So then those cute little friends can can have fun together.
Robot gyms.